Hi, so we're going to be talking about classifying today. We're going to start with a really simple example. You guys know I have a pet that is a dog that is an Australian cattle dog. So I would classify him right here as under the dogs, which is under the pets. But just because I have a pet doesn't mean that my Australian cattle dog is a cat, because he's not under that same circle. So when you're looking at a diagram like this, the things that are dogs are only dogs. A pug, it's only a dog, it's not a rabbit. At the same time, because the circle is in the pet box, it's still a pet. So thinking about that, let's look at classifying some numbers. So here's the main two numbers that we're going to be looking at are rational and irrational. And they go under the big title of real numbers, just like pets. So some numbers, some real numbers, are rational. Rational numbers terminate, meaning their decimal ends, or they repeat, meaning they're a repeating decimal. For some of the examples that may not sort of come to mind when you hear that are fractions and perfect square roots. So irrational numbers are decimals that never end and they never repeat. So let's look at this a little closer with some examples. So here we have rational numbers. Again, it could be a perfect square root, such as the square root of 25, because square root of 25 is 5, which is a whole number, which goes in here. Notice this decimal is rational because it is repeating, and this one's rational because it ends. And fractions, again, are rational. And all these other little numbers in here are also considered rational numbers. And then we also have irrational numbers. Again, they are decimals that never end and never repeat, but they can also be square roots that are not perfect squares. So for example, square root of 6, we already learned that you would have to estimate that because it's a never-ending, non-repeating decimal. So let's do some practice on this. I'm going to show you some examples, and you're going to type in if they're rational or irrational. So 0.25 is rational because it's a decimal that ends. Square root of 25 is rational because it is a perfect square root. 0.2552363, it is irrational because it never ends and never repeats. 0.2525 would be repeating, so it is rational. -3.2 is rational because it ends. 6/11 is rational because it is a fraction. 3/33 is rational because it is a fraction. Square root of 36 is rational because square root of 36 is 6, which is a whole number. On the other hand, square root of 2 is irrational because it is not a perfect square, and as a decimal, it never ends and never repeats. 1/3 is rational because it is a fraction. Square root of 5 is irrational because it never ends and never repeats. Square root of 16 is rational because it would be 4. And pi is irrational because it is a never-ending, non-repeating decimal.